Welcome to the third video, where we continue our journey through the migration project methodology. In the prior stages, we focused on defining a workload, examining both the present and future state architecture, and summarizing the transformation for each workload example. Now, let's delve deeper into the migration analysis phase. At this point, our 12-step migration methodology takes center stage, setting the groundwork for precise effort estimations and crafting a robust project plan for the entire migration project. These will serve as the core of the proposal to the client. Let's use the previously defined third workload as an example, where we migrate an Oracle database and some other components that interact with it. Having established the current and future state architecture, as previously discussed, we've completed the first of our 12 steps. This paves the way for us to collect artifacts associated with the conversion of the database schema, codes of applications, scripts, jobs, reports, and ETL, all part of the workload. Upon gaining access to the schema and code for these components, we can initiate the analysis for steps 2, 3, 4, and 5 within our 12-step framework. For this purpose, we'll leverage a WSSCT that provides a thorough migration assessment reports that include conversion automation details of the analyzed components. These reports highlight potential issues and technological risks inherent to the project. In one of these migration reports, for the Oracle database, you can observe various database object types, such as constraint, table, index, among others. The report offers statistics on both automatic and manual conversions for each object type. As part of the analysis, our migration engineers scrutinize the WSSCT output, reviewing the complexity of database schema objects, the counts of manual and auto conversions, and the total number of each object type, among other things. This reveals the relative importance of each area. Each case that requires manual conversion in WSSCT is called an action item. This report generated by WSSCT consolidates all action items. It assists in identifying the frequency of each conversion issue, enabling a focused approach to the most common ones. Typically, these high-frequency issues will need more manual work. However, this also depends on how complex a particular issue is. For instance, while the occurrence of these action items is relatively infrequent, their complexity means that they will still demand a significant amount of effort. After a comprehensive assessment of these issues, including their frequency and complexity, the migration engineering team delivers their revised estimates of the efforts required for the database schema conversion. After addressing the conversion issues associated with the database schema, we move on to the subsequent steps, which involve adapting code components to smoothly integrate with relevant elements of the future architecture. Let's review our approach to analyzing such components in detail using the manufacturer C++ application. Similar to the database schema, WSSCT categorizes action items based on their complexity and provides time-based effort estimates. Our technical team carefully reviews and refines these estimates before incorporating them into revised conversion estimates for the respective applications. Note that the estimates account for time spent on validating objects that are automatically converted by WSSCT. This is the combined effort estimate for both manual and automatic conversion of the application's SQL queries to the database. Afterward, the team evaluates the effort required for the following stages of application integration: connection mechanism, configurations update, transaction management review, error handling mechanism, and adaptation of existing unit tests. Using this approach, we analyze other applications and code objects within the third, fourth, and fifth steps of the migration methodology, taking into account their specifics. During the sixth step, we explore the collected artifacts for data migration. We design a data migration approach using the following steps. Resolve CLOB data type differences between Oracle and PostgreSQL. Script primary, foreign keys, and indexes for quicker migration. Set up change data capture via AWS DMS. Plan data validation approach. After the sixth step is completed, we utilize the data gathered from all preceding steps to estimate the effort needed to finish the remaining steps. We can see an illustrative example of how the estimations for all these steps converge, encompassing steps 1 through 6 of the 12-step migration methodology. The steps 7 through 9, testing, Performance tuning and DevOps security are usually driven from the analysis of previous steps. Importantly, we place special emphasis on test estimation. This step can consume a significant portion of the overall project effort. In that case, we should consider involving the customer's team to accomplish this step quickly. The steps 10 through 12 of the project analysis cover the required administration steps needed for each project: documentation, project management efforts, and a post-production support. Once we've established the project estimate, our focus shifts to crafting the project plan. Recognizing how the phases are interdependent, our goal is to maximize parallel execution to minimize the overall project timeline. In this video, we explored the phase of artifact collection and analysis within a migration project for a previously defined workload. We've obtained the final cost estimate and project plan. Moving forward, our next video will provide a closer examination of the migration solution document. This document offers a detailed specification and a roadmap of the entire migration project. By combining the estimate with the project plan, we form the basis for the final proposal. This proposal must be submitted to and approved by the client before the migration project phase begins. Thanks for watching, and see you in the next video.